first lesson for college algebra. Now, the first few videos or lessons may be more of a review for you. So feel free to skip what you need to and review what you might need. So don't feel obligated to watch the whole thing unless you need to. So just skip around to the pieces that you need a little bit of a review with. We're going to start out with two different lessons for lesson 1.1. The first part is just going to be talking about how we write sets of numbers and the different ways that we can write different sets of numbers. And then in our next lesson, we will move on to the coordinate plane before we jump into some more college algebra. So let's first start off by defining what a set is. So a set is a well-defined collection of objects which are called the elements of the set. It doesn't matter the order of the elements that are within our set, and sometimes you will most oftentimes see that they are from least to greatest, but they don't have to be in a particular order. Well, then what does well-defined mean, since well-defined is within the definition of our set? So well-defined means that it is possible to determine if something belongs to a collection or not. So if an element belongs to a specific set, we're going to use this particular symbol. It looks like an E that is facing to the right. So if the element X belongs to set A, we say that X is an element of A. If it is not a set, so maybe it doesn't belong to a set, we can put the element with a cross through it. So this means that the element is not in the set of A. There are a few different ways in which we can describe sets: a verbal method, a roster method, set builder method, interval notation, or the graphical method. Either one of these are appropriate. Typically, we will utilize the roster method. We will use set builder or interval notation. So these are the three main ones that we're going to focus on within our course. Moving on to the second page here. Let's talk about the real number system itself. So on the left, I have the definitions of the real number system. The empty set is represented with an O with a slash through it. We could write it utilizing the roster method with brackets. There's just nothing in it. Or we can write it in set builder notation, so X such that X is not in X, which seems kind of counterintuitive, but ultimately this is the set that has no elements whatsoever. We then have what we call the real number system, and we know that the real number system, you're either going to be a rational number or a non-rational or irrational number. We also know we have imaginary numbers. Those are complex numbers that are not real numbers, so that's a different dimension that we'll talk about a little bit later. So we have the natural numbers, we have whole numbers, integers, the rational numbers, the irrational numbers, and then, of course, the real number system itself using the hierarchy. So we represent the real numbers with the letter R. We represent the irrational numbers using the letter P. We represent rational numbers utilizing a Q. We can represent integers utilizing the letter Z. We can represent whole numbers utilizing a W. And the natural numbers utilizing the letter N. On the right, you see some questions. 3 and 54 hundredths is known as which type of number? Since 3 and 54 hundredths can be written as 3 and 54 hundredths or even 354 hundredths, we know that this is going to be a rational number. I know it's a rational number because it is the first number that's on the hierarchy. It cannot be an integer because it has a fraction involved in it. It's not a whole number and it's not a natural number. However, which set of numbers does not include -8? Which does not include -8? Well, -8 is an integer, and if it's an integer, it's also a rational number. So it does not include whole numbers, and it does not include natural numbers. Just notice the negative values are not listed there. So it does not include whole numbers, and it does not include natural numbers. And ultimately, it also doesn't include the irrational as well. But because it can be written as a fraction, it is also a rational number as well. Integers, so now I'm looking at just these integers here. Integers are a combination of both whole numbers, these values here, and the negative numbers as well. So whole numbers and negative numbers as well, since whole numbers include 0 and 0 is included within the integers. Let's talk about how we can write the different ways of describing the sets themselves. We can use a graphical method where we draw a line segment to show the interval of numbers, remembering that we use the open circle on the line if we want to exclude a specific number, and then a filled in circle if we want to include. We use left and right arrows to determine which direction the values continue on to infinity. We also can utilize set builder notation where we start with a bracket and then we have x and then a vertical line, which means x such that. And then we put those conditions on. We can put conditions on so that x equals a specific value. Perhaps x can be less than a value, less than or equal to a value, greater than or equal to a value, or x is in between two values. We do not just want to write the inequality symbols using the infinite symbol. We'll want to join equalities utilizing the word or even using the word and then finish with a bracket itself. And we'll see these happen coming up. We'll see examples of these different pieces. When I'm looking at interval notation, we want to use open parentheses if we want to exclude our values. We want to use closed brackets if we want to include those values. So I like to think of parentheses when we have open circles and then brackets when we have the closed circles. Many of us have much experience with open and closed circles. Also within interval notation, we can use positive infinity and negative infinity. We sometimes utilize the union symbol, which is just a U, a big U, which symbolizes the word or. And then the intersect symbol, which is an upside down U, which represents and. All numbers that are within the interval notation, typically we write in ascending order from left to right, just for easier reading. If the interval goes on forever to the left, start the interval notation with that as well. So if it's starting and it's going forever on the left, we'll start with negative infinity, and then we'll go to a certain location. Similarly, if the interval goes forever on to the right, we will have some stuff over here, and we will go to positive infinity. Notice that within infinity, infinity never stops, so infinity will always have a open parenthesis. Whenever a graph consists of multiple line segments, we're going to write out each interval from left to right, putting the union symbol between each interval to join them together. So some examples if we want to combine some sets here. Let's look at the intersection of A and B. So if I first write out A is between -5 included, so notice I have the closed circle, so -5 to +3, and +3 has the open circle, which is why it has the open parenthesis. And let's let B be the interval between 1 open circle to infinity. Let's find the intersection. So the intersection is exactly what it sounds like. Where do these overlap or intersect with one another? So when I look at the intersection of them, I'm looking for where do they overlap. And I notice they overlap on the interval between 1 and 3, and noticing that those are both open circles, so that we would utilize parentheses. So the intersection of A and B where they overlap is between 1 and 3. But what about the union? So the union means or, this or that. So as I'm looking at my original, what each one means, I've got them listed over here. So I've got the bracket, the open circle to infinity. So if I want this or that, that means all of it, combining all the pieces together. And notice that we are starting on the farthest left is from -5 included, and we go all the way to positive infinity because we do have this arrow that will continue forever. Let's utilize some set builder notation to help us here. The union of A and B in set builder notation can be listed as here. So our A and our B, let's see here. This is A and this is B. So if I write it out utilizing interval notation, we see that this is negative infinity all the way to -2, which is included. So I'm using my bracket. And B on this particular side, I also should say that X is obviously then less than or equal to -2. Similarly, we are starting at 2, and we are going to positive infinity with an open circle, and this X is greater than or equal to +2. So let's find the union of both of these written in set builder notation. So A union B is equal to, again, set builder notation, we start with a bracket and we say X such that X is less than or equal to -2, or because I'm combining them together, or X is greater than or equal to 2. Utilizing interval notation, kind of already have it written out above, so A union B, negative infinity to -2 bracket, union, bracket 2 to positive infinity. So just different ways that we can write and represent each one. You will notice in our homework that it'll tell you specifically how they want it written. So let's look at some examples to kind of put all of this together. What is the set S expressed in set builder notation? Set builder notation. So if I'm looking at this, I see that I have a bunch of different values over here on the left that are continuing forever and ever, but it goes to then -1, 0, 1, 2, 3, 4, 5. So 5 is the highest value that we have. So it's appearing that our values are less than or equal to 5, since 5 is the highest value in our set. So our set then is equal to X such that, X is an element in our integers. Notice I don't have any decimals, I don't have any fractions, but I do have negative values, so it has to be an integer, such that X is less than or equal to 5. And then I close my brace here. What does this mean in words? X is an integer. Again, my vertical line means such that x is less than or equal to 5. That's how we would verbally say that. Express the set of numbers shown on the number line in set builder notation. So set builder notation. We want to write it just as we did before in set builder notation, except I'm given the number line to review. So noticing on my green line here, I'm going from negative infinity to 7, and 7 is excluded. I'm skipping over some stuff, so or, and now I'm starting back at 10, and I'm also going to positive infinity. So I've written it in interval notation, but it's asking for us to write it in set builder notation. So let's say our set is A, and notice that I am having some whole numbers here. It does appear that I could go forever and ever on the left, so it might include all of the integers. So x is an element of the integers such that x is less than 7 or x is greater than or equal to 10. Let's look at another example. It's asking us to write the inequality in interval notation. From time to time, I find it beneficial to draw a picture. It's easier for me to see what's going on. So if I want to write this in interval notation here, just kind of drawing a picture of what this looks like on the number line. I've got 4 and I've got 9, where 4 is included because it's less than or equal to, and I have 9, which is just less than. And x has to be somewhere in between here. And that certainly helps me write the interval itself. So let's say our set A is equal to 4 included all the way through 9, which is excluded. And now we've written it in interval notation. What inequality? So now we're looking for inequalities. Again, here's the inequality that we started with, so we're kind of working a little bit backwards here, is defined in interval notation by negative infinity to negative 2 excluded, union, inclusion of 3 to positive infinity. So again, what I'm first going to do is just draw a picture to see what it looks like, which might help me write it in inequality notation. So I'm going to sketch a number line here. We have negative 2 and we have positive 3. Negative 2 is excluded, and then we're moving to the left. 3 is included, and we're moving to the right. So this will certainly help me write it in inequality. So let's say A is equal to x less than negative 2, or x greater than or equal to 3. And our final example, we also want to write it as an inequality when I'm given the interval notation. From negative infinity to 3 included the intersection of 1 to positive infinity. So I'm looking for the intersection. Where do they overlap? Where do they overlap each other? So let's draw a picture. Again, I think drawing pictures is helpful to see what's going on here. So my numbers that we have as our endpoints are 1 and 3. 1 is included because it has the bracket, and 3 is also included because it also has a bracket. And 3 this left side goes from negative infinity to positive 3. So negative infinity to positive 3 is going to the left. And 1 is going from here to positive infinity. Again, we're looking for where are they overlapping. So our graph is overlapping in this area here. And we want to write that as an inequality. So our set is equal to 1 is less than or equal to x which is less than or equal to 3. So x is in between 1 and 3 in this instance. And this concludes our first lesson for college algebra. You may now feel free to hop into My Open Math and give part of the homework a try. If you come across items that you're not sure how to do specific with the coordinate plane, or you need a little review, skip those ones. We will work on them together when we meet next.